Okay, so here we are able to learn that R1 has learned that 101.2 has MAC address A, and here we can see PC1 recently learned that 101.1 has MAC address B. So this packet which is waiting here, it will generate here echo request. In echo request, it will add source IP. Source IP is 101.2. Okay, destination IP is, you can see here, I am typing in short 102.100. Source MAC. Source MAC you can see here. Yeah, source MAC is here A. And destination MAC, as I told you, if the destination is not in same subnet or network, then packet will go directly to the gateway, and gateway MAC address you can see here B. Okay, now this packet will be sent to switch. Okay, switch will perform address learning, which is already learned. Now it will perform forward filter decision based on destination MAC. B is learned from the interface, so this packet will be offered to R1, or we can say branch 1 router. Branch 1 router will remove the MAC. When it will remove the MAC, okay, it will check what is the destination. Destination is 102.100. So this packet will be delivered to branch 2. So here the received packet is echo request with source IP 101.2, destination IP 102.100. This packet will reach at the branch 2 router. Now branch 2 will check, okay, what is the destination 102? Yes, this is matching with my lane. So what it will do, it will generate say ARP request. Now please, branch 2 want to communicate with server, it will check it is in the same network which I am connected to, whom I am connected. So now this branch 2 router want to communicate with server 2, so it doesn't know the MAC address, so again it will generate an ARP request. In ARP request it will say, okay, source IP is 102.1, this one, source IP will be this one. Okay, destination IP, I want to know the MAC address of 102.100, so here 102.100. Okay, now source MAC, you can see here source MAC we have defined here C, source MAC address C, destination MAC we don't know, so it will add 12 times F. This request will offered from R1 to switch. Switch will learn address learning. What is address here? Source MAC C. It will learn the source MAC C. After learning source MAC, it will check destination MAC. What is the destination MAC? Broadcast address. So it will flood it to PC and the server. PC will ignore because its IP address is not 102.100. Whose IP address is 102.100? Yes, server 2 IP address is 102.100. So it will give reply. Server will give reply. In if reply, it will say, okay, source IP. Source IP is this one, 102.100. Destination IP, who is asking? 101 is asking, so it will add, okay, 102.1. Source MAC, my source MAC address is here D. Destination MAC, okay, destination MAC you can see here C. Yeah, destination MAC address is C. This request reply will be offered to switch. Switch will perform address learning based on source MAC, yes D. Then it will check what is the destination C, so it will forward it to the branch 2 router. Now branch 2 router is capable to learn that 102.100 has MAC address D. Now what will happen? This packet, okay, this packet will attach with the source MAC here. Okay, we have to clean some diagram. Okay, have patience please. Okay, now this packet which is waiting here, then it will be encapsulated into a frame. Okay, it will add, okay, source MAC address you can see here, source MAC address C, and destination MAC address which is recently learned, destination MAC address here, destination MAC address is D. Now this frame will be offered to the switch will perform address learning. C already learned, no problem. What is destination MAC address? D. Now it will offer to the server. Now, when the server will give reply, okay, what the packet contain echo request, what it will generate, okay, it will generate echo reply. In echo reply, it will say, okay, source IP address is 102.100, okay, and here the destination IP, okay, destination IP address is 101.2, source MAC address, yeah, source MAC address is here D, and destination MAC address is here, we can say C. This echo reply will be generated by the server will offer it to the switch will check, okay, address learning, address is already learned at the interface, okay, then it will perform forward filter decision based on destination MAC address is here C. Through the interface it will offer to the router will remove the MAC, will remove the frame, it will check what is the destination 101.2, this frame will be offered to R, or we can say branch 1. Okay, now this message will be received via branch 1. Okay, what is echo reply? In echo reply, source IP address, okay, you can see 102.100, destination IP address is 101.2. Now this branch router will forward it to the PC1. Okay, as I told you, if this PC want to come, this router want to communicate with PC1, okay, it will add here source MAC, okay, source MAC address is here, we can say B. Now the destination MAC address, branch 1 recently learned that 101.2 has MAC address A, then it will add MAC address A. Now this reply will be offered to switch will perform address learning based on source MAC is B, okay, that is already learned, no problem. Then forward filter decision based on destination MAC, yeah, MAC address A is learned from this interface and it will forward it to the PC. Now which request was sent from the PC1? Yes, echo request, and source was 102, destination was 101, source was 101.2, destination was 192.168.102.100. And now what is receiving this PC? This PC is receiving echo reply from the source 102.100 to the destination 101.100. So there are two rules in the routing. Okay, first, if the destination is in the same subnet or network, then a device directly forward the packet to destination. If the destination is not in same subnet or network, sorry, then a device directly forward the packet to the gateway. If the destination is in the same subnet, ARP request is used to find out to the destination MAC. If the destination is not in the same subnet, then ARP request is used to find out destination MAC. Sorry, gateway MAC. Okay, types of routing. Here, for better understanding, we required a clean diagram. Okay, now after learning routing, that what is routing and what are the routing rules, we have to learn that what are the routing types. Okay, so there are three types. First is static, second one is dynamic, and third one is default. Okay, so what is static routing here? In static routing, we define routes manually with appropriate next hop. And in static routing, we always define indirectly connected network. Okay, if you want to implement routing, first method you have here static. As you can see on the PPT, in static routing, we define routes manually. If you are a network engineer, network administrator, or network consultant, if you are performing static routing, then you have to define static routing manually with appropriate next hop. And in static routing, we always define indirectly connected networks here. So okay, in static routing, we always define here, yes, indirectly connected networks. Next route, okay, advantage of static routing. If you are implementing static routing, that is easy to implement. How we can say it is easy to implement? Yes, there is a command IP route destination network mask and next. So this is the command of static routing: IP route destination network destination mask and next hop. So here we can say, if you know the command, you can easily implement the routing. Next is here, the advantage is less CPU overload, because you will provide the routes information, so there is nothing to do by the router CPU, that you will provide instruction and it will follow the instruction. So here we can say there is no load on CPU. Next one is less bandwidth consumption. What is the meaning of less bandwidth consumption? Is that, okay, suppose you have a dial-up link. Dial-up links means how much you will use, you will provide. If we are talking about dynamic routing, they periodically sends updates to each other, or they send hello. Whether whatever your lane is communicating or not, that is not problem, but still they are communicating to each other via hello. So your link is being utilized, so you have to pay for that. So here in static routing, what's happened if you are using static routing? When lane traffic will be initiated, then the link will be used, otherwise link will not be used. So here we can say less bandwidth consumption. But along with advantage, it also contain disadvantage, not scalable. If, okay, static routing is good at force at the small scale, but if we are talking about a large scale network, then it is not reliable, because if you have redundant link, you have to set redundancy. Okay, if primary link will goes down, you have to change the AD value. So here we can say that static routing is not here scalable. Next one is default routing. Okay, it is used on stub router or stub network. You can also use another type of routing. For example, we have a network that's R1 connected with R2 and R2 connected with R3. So here default routing, it can be used on stub router or network. Now question is, what is stub router? A stub router has only one entry or exit point. So here we can say R1 and R3, they are the stub network. So here you can use default routing at the R1 and you can use default routing at the R3. It can be reduce the size of routing table. Okay, it's not only used on stub router. If you want to reduce the size of routing table, you can also use the default routing. But here it is a limitation. It can be cause loop in the network. So how it will, it can be the cause of loop if you have such kind of connectivity. Suppose if you have two branches, branch 1 and branch 2, only two branches. Now we can see both are stub. Now you have performed default routing toward branch 2, and here you have performed default routing toward branch 1. So in this scenario, it can be cause loop in the network. How? For example, 101.0, 102.0, this is 1.0. Now if you are trying to ping here 103.0, so it will generate a source packet. Source packet will be 101.0, destination IP, then 103.0. This information will go to the router. Router will check what is destination. I don't know. Okay, I will forward it to the branch 2. Branch 2 will check what is the destination. 103, I don't know. Okay, I will forward it to the branch 1. Now they will play with the packet until the TTL value will not zero. When the TTL value will zero, the packet will be discarded here. So here we can say that if default routing provides you advantage to reduce the size of routing table, you can also use default routing at the edge routers, which is connected to the service provider, internet service provider. Along with these features, it can be cause in the loop in the network. But if you don't have such kind of network, then there is no problem here. Okay, next is here dynamic routing. Okay, till now we have learned that what is static, what is default. Okay, next one is here dynamic routing. In dynamic routing, we use routing protocol. They dynamically learn about route and do send route information to their neighbor router. In dynamic routing, we always define directly connected network. For better understanding, we have to go through the diagram. Okay, please have patience. Okay, branch 1 that is connected with branch 2. Okay, It's one network 101.0, it's network 102.0. Okay, and here the network is running 192.168.1.0. Now we want that these routers learns their routes automatically. So what we have to do here, we have to implement here dynamic routing. In dynamic routing we will perform at branch 1. Yes, you have network 192.168.1.0, as well as you also have 192.168.101.0. Same thing we will perform here, that you have network 1.0 and you also have network 192.168.102.0. When we will tell this information to these routers, what they will do, they will exchange this information to each other. When this information will receive by branch 2, okay, branch 2 will check, okay, what it is saying, it is saying I have 192.168.1.0. It will check, okay, I have already, what is the new 192.168.101.0. Now it will automatically learn, yes, 192.168.101.0. When this packet will be, information will send from branch 2 to branch 1. Okay, this information contain, our branch 1 will check, okay, what is branch 2 telling, branch 2 telling I have 192.168.1.0. okay, it will say I have the same. So what is new, it will say, okay, 192.168.102.0. so okay, yeah, this is new, 192.168.102.0. so in this way we are watching here, in dynamic routing we use here routing protocol. They dynamically learn about the route, as you can see in this video or in this nugget. Okay, they will dynamically learn about the route. And note here, in dynamic routing we always define directly connected networks. Okay, now next is, here you can see routed protocols. When we talk about routing, then some terms comes routing protocol and routed protocols. So routed protocols are those protocols which have capability to send data from one device to another device. For example, IP, IPX or AppleTalk. For better understanding, we have to draw a diagram. Okay, suppose this is branch 1, branch 2. It is connected with switch. Switch is connected with PC. Same scenario is here, that is connected with switch and switch is connected with PC. Now this PC want to send data to PC2. This is our PC1 and this is PC2. Now both PC want to communicate. So which routing protocol will be used to carry data? That is called routed protocol. And their example IP, IPv6, AppleTalk and IPX here. These are the routed protocol. Okay, but when the routes will be exchanged, for example 101.02 from branch 1 to branch 2, and branch 2 will exchange, okay, 102.0 to, okay, R1 will say I have 101.0, this information will send to router, and router will send, okay, I have 102.0, this information will send to branch 1 router. Okay, this information will be carried via routing protocols. Okay, routed protocols are those protocols which have capability to send data from one device to another device. Now the term is routing protocol. Routing protocols are those protocols which dynamically learn about route and do send route information to their neighbor router. But remember it, they, okay, route information will be exchanged via routing protocol, but routing protocol will work on routed protocol. First they will use IP, and before over IP you can use OSPF, you can use RIP, or you can use EIGRP. Whenever you want to send data from one device to another device, whatever or where it is PC or router, you have to use routed protocol. But if you want to exchange only routing information, that information will be exchanged via routing.